Conditionals, one of the most important things in all of computer science. The entirety of computer science, remember this. We've already covered three of them: input and output, algebra, making variables. Today we're going to do conditionals. We're going to either do one thing or do another thing. It's where all intelligence in a computer program comes from. So every time you hear something about AI, every time you play a video game and the game reacts to you, all of that has to do with conditionals. That's where all the brains are inside of a program. So we call these things conditionals. We call them branches sometimes. If you've ever seen a flow chart, more power to you. Like when I was in middle school, they're like, oh, if you're going to be a programmer, you have to learn how to flow chart. And they taught us how to, all the different symbols, like a parallelogram means this, and the thing with a curvy line means that. And nah, nobody uses them. We might sketch out something with like branches, but I'm showing this to you because you can see visually what happens with an if statement or a conditional or a branch. Is that the program's running, and then it comes to a decision point, a conditional point, a branch point. And the program decides, I'm either going to do one thing or I'm going to do another thing. And one of these things might be empty. Like it might just be, well, if it's false, don't do anything and just continue on. Okay. So it's just running down the line. It comes to some conditional. It evaluates if something is true or false. If it's true, it executes all the code within some curly braces over here. If it's false, it executes codes inside of another curly brace. And again, one of these things or both could be empty. So it does one thing if it's true and does nothing if it's false, for example. That's why this is called a branch. It goes running and then it branches. All right. So here is, there's four different ways of combining together the conditionals in C++. We're going to go through all four of them. And I'm going to have you guys write some code. I'm going to pause it after each one of these slides, and I'm going to have you guys write a line or two of code to show me that A, you're paying attention, and B, that you're understanding. So let's go through this one step at a time. So first of all, you guys should understand this by now. We're making a variable named x. It's initialized to have a value of 0. It is an integer. Integers hold a value, a whole number between negative 2 billion-ish and positive 2 billion-ish. Okay. We're then going to read from the keyboard into x. And then we're coming to the new thing. So if the value of x is less than or equal to 5, it's going to print out 5 and under are free. Like, you're at a baseball game or something, you get free admission if you're under 5 and under. And then if they are over 5, well, it just skips over this, and then it prints out welcome to SeaWorld. So if they're under 5, it'll print out 5 and under are free, welcome to SeaWorld. Because remember, when the conditional ends, it just keeps going. If they are over 5, then it just skips over everything between the curly braces here, and it prints out welcome to SeaWorld. So the smooth parentheses here is the conditional, okay? And so this is going to evaluate to true or false. So is x less than or equal to 5? Well, it depends what the user types in. Okay. So if the user types in 3 is in fact less than or equal to 5. Everything within the smooth parentheses is true. Therefore, it runs all of the code between this curly brace and this curly brace. If the user typed in 10, this would evaluate to false because 10 is not less than or equal to 5. Thus, it skips over everything within the curly braces here. It runs none of it, and it moves on to the next line of code and prints out welcome to SeaWorld. So what I'd like for you guys to do now is write a couple lines of code and paste it on chat when you get it done. I want you to ask the user their age, and if they are 65 and up, print out, you get the senior citizen discount. I'm going to pause the recording here, and then when we come back, I will look at your answers and give you my answer as well. So I'm going to pause for a couple minutes. You're going to write code that will ask the user for their age. It'll input it into a variable, and then if the age of the user is 65 and up, it'll print out you get the senior citizen discount. Otherwise, it prints nothing. Okay, begin. All right, we're back. So I'll just stick with what we had from before. Please enter your age. If your age is greater than or equal to 65, then you will see out. You get the senior discount. Now, a couple notes here. I saw some people do this, which, no. C++ greater than or equal to is greater than first, then the equal sign. This kind of looks like an arrow. I don't know. So, nah, you got to do greater than first. Another note is that if you have exactly one line of code, you can actually drop the curly braces. So the curly boys are only needed if you're going to have 2 or more lines of code. Something like that. So this is, a lot of professors recommend you always use the curly boys. The reason for that is because it looks like right now that if the user types in 65 and up for their age, that it'll print, you get the senior discount. Maybe I'll add this. The senior discount is off. But if I compile this, you'll see I'm getting a misleading indentation error. And the misleading indentation, the ladder is misleadingly indented as if it were guarded by the if. Okay, that's because there is no curly brace around this. You need the curly boys. Okay, like that. Remember what the if statement is saying is if the conditional is true. In other words, if whatever expression within that the smooth parentheses is true, it evaluates to true. So if the user types in 70, is 70 greater than or equal to 65? Yes, it's true. If that is true, then everything between the curly braces gets executed. And people who leave off the curly braces will sometimes get into situations like this where they think that it's going to run the 2 lines of code, but it's not because there's no curly braces there. That said, this is perfectly valid C++. So you either need to have 1 line of code or curly braces surrounding a block of code. Either of those will work. So if you have this, this will run, you get the senior discount if the age is over 65. So you cannot do this. What happened here? Yeah, so this is not valid code. Don't try and combine too many different things together. I saw yesterday somebody was like trying to do like C out, age minus 10 is equal to 50. Like, just don't, for now, just don't do that. If you're going to do an input, do an input. Like if you're going to read into age, read into age. Like that. This is how you read from the keyboard. Okay? Don't try and put too many things together for right now. Yeah, you could also use print line if you wanted. Okay, so if we run this code, if I type in 100, I get the senior discount. If I type in 10, nothing gets printed to the screen. And the reason for that is it just skips over the if statement because it's false. So everything within the curly braces it runs everything within the curly braces if the conditional is true. If the conditional is false, it runs none of them. Okay. Next up is the if-else block. And so the else block runs if the conditional up here is false. So if x is less than 10, it's going to print yippee. If x is not less than 10, it's going to print woohoo. So take a moment, look at the slide, and tell me, what is it going to print to the screen, given that x is equal to 10? Is it going to print yippee, or is it going to print woohoo? Cast your votes now. Maybe we can put up a poll onto Discord or something. That is correct. It is going to print woohoo. And so the way that the compiler evaluates this, and it's really important to understand how the code actually gets run. Okay, it goes through it a line at a time. Okay, so it starts off by creating a variable named x, setting its value to 10. It's an integer, whole number between -2 billion to +2 billion. Then it's going to come in here and say, is the value of x less than 10? Everything within the smooth boys evaluates either to true or false. In this case, it's going to evaluate to false. So everything within the if block gets skipped. And it comes over to the else block. Because the else block runs when this block doesn't run. You always get one or the other, not both, and not neither. You will get one of these two branches. You will, every time you run this code, no matter what value x happens to be, it's either going to print yippee or woohoo, but not both and not neither. It is guaranteed one of those two will print. They're mutually exclusive. So the else statement runs when the if statement up here is false. And so if it is false that x is less than 10, then it will print woohoo. So let's do another thing here. And so now I would like for you guys to modify this so that if the person is under 65, it will say no senior discount for you. All right, so add an else block here, add else and some curly boys, like this. Some students, for whatever reason, try putting a conditional on the else, which you can't do. You cannot put a conditional on else because the else's conditional is actually the ifs conditional, the smooth parentheses. Is if the ifs conditional is false, then the else is run. So you cannot do this. This is illegitimate C++, right? You can't. Floss is not allowed. No, you never have parentheses on the else. Just curly boys. Okay. So go ahead and take a moment. I'll pause the recording. And please write some code that if the person is not over 65, it will print out, sorry, you don't get the senior discount. All right, so the answer is else, cout, you don't get the senior discount. Simple as that. All right. So one of you said if x is less than or equal to 64, you get the senior discount, which is backwards. So if you do that, then you're giving the senior discount to people like me. Unless these look pretty good indeed. All right. Next up is the if-else if. There's four different ways, like I said, you can structure an if statement. This is the third way. And this one, you really have to understand that these things get evaluated in order, okay? So here we've got an integer named x, whose value is 12. It's going to run through these conditionals one at a time, okay? So it's first going to say, is x equal to 0? No. So it skips over this line, goes to the next one. Is x equal to 7? No. Skips over it. So what does this print out to the screen? What do you guys think? Nothing, exactly. With the if-else, it's guaranteed it's either going to print yippee or woohoo. It's going to do one. If it does the one, it does not do the other. If it does the other, it does not do the one. It is guaranteed one of these things is going to get printed out. With this one, it just checks, should I run this? Nope. Okay, move on to the next one. Should I run this one? Nope. And if it ever does run one of the lines of code, it skips everything below it. And so I'm going to pull up some more complicated code, and we'll see if you guys can figure this out. So if we open up the ifstuff.cc, so let's give a value here of like 15. Okay. So let's go through this. So the value of x is 15. We've made a variable named x, type integer, whose value is 15. When you evaluate, we've got all these ifs, else ifs, and else's in here and things like that. When you evaluate this, you go through one line at a time, right? And don't just like look down here and be like, oh, you know, I can see something that it matches. You have to take it from the top. Okay. So let's go through this one at a time. Is it true or false that x is equal to 14? What do you guys think? True or false? And you can have multiple lines inside of these things. You know, you even do algebra x times equals 100. Like, you don't just have to do print statements. It is false. Okay, so we skip over everything between these two curly braces and we come to the next one. Else, is x less than 15? Is 15 less than 15? What do you guys think? True or false? That is false. So it will not print Harambe 2024. Is 15 greater than 16? What do you guys think? True or false? So it's going to skip over, because this conditional here is false, it skips over everything between the matching parentheses. Okay, so all of this stuff you see on the inside, none of that gets evaluated. It skips over all of it because this x is greater than 16 is false. So it skips down to here, and then we've got an else. The else is the catch-all. If everything above me in this if, else if, else if, else if, else if everything above me was false, then I'm going to print what to the screen? So what ends up getting printed to the screen if x is equal to 15? What do you guys think? It's for the presidential campaign, so perhaps it's illegal for me to be campaigning for Harambe, but so it'll print out Harambe 2024 and Harambe 2028. Remember, it prints out everything between the curly braces here, right? So everything between the curly braces gets executed, and then it will continue on down here with whatever we end up putting down there. Okay, let's go through another example. Maybe we'll set x equal to 150. So if x is equal to 150, let's evaluate it together. Is x double equal to 14? By the way, double equals means equal to. A very common mistake students make with if statements is they use single equals instead of double equals. Single equals means assignment. Set the value of x to something. Double equals means comparison. Compare the value of x to 14. So is it true that the value of x is the same as 14? A candidate you can get behind. Is it true that the value of x is the same as 14? False. Good. So we skip over, again, everything between the curly braces here. Skip. And then, is it true that x is less than 15? True or false? Is x less than 15? Also false. So we come down to here. Is it true that x is greater than 16? That is true. So we're going to execute now all the code inside of the curly braces here. And after we're done with it, we skip over everything after, because the else clause is going to get skipped because this one here is true. Okay. So we're going to now execute all the code inside of here. It's going to print out do curly boys first, because Min Curly was making a point that when you're writing code like this, if x modulus 2 double equals 1, and you're having all these ifs, else ifs, else if else, it gets like it's hard to remember like how many open parentheses you have, how many open curly boys you have. So a lot of IDEs will do this for you. I personally hate it when they do it for you, so I actually have it disabled on the server. I like to do it myself manually. I type open curly boy, return, close curly boy, and then Shift O to come up to the inside of it. The reason why I hate it is because, like, if I have to do anything complicated, I just end up having all, like, the IDE just creates all these close parentheses for me and close curly braces for me, and I'm like, I don't know which ones go with which, you know, and I'm just typing and it just gets in my way. And so I'm a fast enough person that I actually disable that help, so I can just do it myself. So you can come in here, and then if you're gonna have an else, you can come in here. If you don't want to do anything, You can always put a semicolon. A semicolon is perfectly valid C++. This is the do nothing command, or the no op command. If x is odd, don't do anything. Else cout x is even. New favorite line of code, yeah. In general, you don't see people like write code like that. Maybe you do. And even worse, like if you have something like this. Like this is kind of evil. Like I have seen this in the wild. This means if x is odd, do nothing. Otherwise, print out x is even. That little guy there is one line of code, right? So you don't need curly braces. This will get you though. Like, do not, like, I highly recommend you don't write code this way. Just because our eyes tend to skip over semicolons after a while. If you really wanted to, you could do that. But I would definitely put a comment there saying, do nothing if x is on, right? Just make it absolutely clear to the people reading your code that this is intentional. Maybe in the future, I'm going to put something here. For now, though, I'm just not going to do anything if x is odd. That's fine. Okay. Still, I would probably write the if statement differently. You know, probably do that instead. You know, sometimes you just have a placeholder or something, and that's fine. Okay. And you can always put the curly braces around it. See, that's what I'm talking about. Like it very helpfully gave me some comments and not what I wanted. All right. So x is 150. It's over 16. So we come into here. What is 150 modulus 2? Remember, modulus is the remainder operator. What is the remainder? How many times is 2 divided into 150? 75 times. With a remainder of what? What is the remainder when you do x modulus 2? 0. Okay. There's no remainder. 2 divides evenly into 150 75 times. So is the remainder 1? No. So we end up doing the else block and output x is even. You guys with me? And so all of these if statements can be nested inside of each other. It's very common, by the way, to have, you know, maybe 2 or 3 levels of if statements deep. If it gets more complicated than that, sometimes you have to, I guess. But it can get, like, the logic on programs can get really complicated when you got if statements inside of if statements inside of if statements. And there's all these ifs and else ifs, and then they don't work, and you're like, oh, Lord, you know. What have I done to provoke you, mother? You know. So this code here, if x is 150, is going to print out x is even. What if there's 151? What is this going to print to the screen? If x is 151, what does it print to the screen? Follow logic. Nothing, right? It's going to come through here. That's false. That's false. That's true. That's true. Does nothing. And then it skips the rest. All right. Let's maybe add one more thing here. Else if x is greater than 100, cout x is a big boy. What about now? What is the program going to print now? Now that x has a conditional specifically for being over 100. What is this going to print to the screen? Take a guess if you don't know. Being wrong is a great way of learning. $100 something? X is a big boy? Nothing? We got 2 votes for nothing, 2 votes for printing out x is a big boy. 3 votes for nothing. So, remember how we evaluate these things, right? So, come in here, Just take it from the top. Is 151 14? Nope. Skip. Is 151 less than 15? Nope. Skip. Is x greater than 16? Yes, it is. Is x an odd number? Yes, it is. What does it do? Nothing. And then it skips over this part and it skips over that part. So even though we have a specific clause in there specifically for big boy x's, it never runs, because this x is greater than 16 will always happen prior to this happening. So this block of code here can never happen. This is a dead branch. It is a branch of code that can never get activated, because if any value that's over 100 is by definition over 16 as well. It was just bad coding on my part if this was a legitimate program. Okay. So, you got to be careful with these things. Yeah. So, you got to be careful. A lot of students, when they read these codes, like they'll read it from the bottom up, and they're like, oh, look, yeah, x is over 100. Yeah, you got it. That's why I'm trying to teach you guys. You got to take it a line at a time, go down, skip, go down, go in, do nothing, skip the rest. You got to think like a computer to be a good computer scientist. All right. Go back to slides here. All right. What is this going to print to the screen? So we got x equal to 0. We got an if, else if, else if. What is this going to print to the screen? It just like me for real. What is this going to print to the screen? Very good. Yes, it will print if x is. It will print out x is less than 10, right? Because again, we evaluate these things one at a time. Is 0 less than 0? I hope not. Skip. Is 0 less than 10? Yes. So this block of code runs and it skips the rest. And like I said, you can also have an if, else 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 if, else. And the else at the very end runs only if all of the ifs and else ifs above it are all false. If all of those things above it are false, then the else statement runs. So for example, if you're getting input, you can say if the input is A, do something, else if the input is B, do something, else if the input is C, do something. And then, you can go through all the letters, and then at the bottom you can have an else. Just be like, I don't know what letter you're typing, but it's not English. You know what I mean? So like to handle like if there's a Japanese hiragana input or something, or an exclamation mark or a quotation mark or something like that. The else is like a catch-all that if none of the above activated, it'll activate. So this code here, x is 0. What's it going to print? A, B, or C? We know it's going to print one of them because we got an else in there. So we know it is going to print one and only one. But which one is it going to print? What do you guys think? A? Are you sure about how confident are you that this code will compile and run the way you think it is, Luke? Nathan has a vote for B because x is 0. Anyone want to take C? 100%. 100% confident. All right. Are you willing to bet your entire letter grade in the class? Dang it. Are you willing to bet your entire letter grade in the class that this code will compile and run properly and print out A? Ignore this. Smart man. All right. Yeah. All right. So do you concur that this is the code from the slide with a boilerplate added, what we call the magic, the hashtag include IO stream using namespace standard? Is something that'll become second nature to you guys after you've written enough programs. So Luke, what do you think? Do you concur that this is in fact the code from the slide? Looks good. All right. Now remember, all of your points in the class are on the line. Does not compile. So unfortunately, Oh, wait, no, you didn't take the bet. All right, good. So, uh, why did it not compile? Well, as it turns off, as it turns off, as it turns out, these smart quotes that you get in Microsoft Office, Microsoft PowerPoint, Microsoft Word, these things actually don't compile. So when you type in a double quote, it curves it for you, but C++ only needs the vertical, only works with the vertical double quotes. So if you put in a smart quote like that, if you try copying my code from the PowerPoint into your own code, then you will probably get a very baffling error message like the one we just saw, which is extended character smart quote is not valid in an identifier. So it's also a valuable lesson because I can use this moment to teach you how to read error messages. So what is the name of the file that the error was in? What do you guys think? It's right here. When you're reading an error message, it will tell you the name of the file. Yep, right? And then it's going to tell you which line of code it's on. So :6 means on line 6, character 21. So file, line, character. So like row, column. That's where the error is, or where it thinks the error is. Because the line number of an error does not always match where the bug is. I can show you that in a second. But let's say that, okay, we got an error and we want to jump to line 6. Now, if you have a file that's this big, you can just, go down to line 6 and it'll tell you down here, line 6, whatever. But if you're on like a multi-100,000 line of code thing, it takes a long time to page down, you know what I mean? So there is a shortcut in Vim to go to line 6, and it looks like that. So if you vim hehe.cc +6, that will start you off with the cursor on line 6. Okay. And you go 22 characters to the right if you want. Okay. So if I replace these with straight quotes, you will see that, replace the C with a smart quote there. You'll see that the code should now compile. Okay. And A is in fact the right answer. Very good, Luke. But let me show you what I mean about the line numbers not always being exactly right. So what am I missing? Anyone see anything obvious that I forgot to type, which happens all the time when people write code? This is why I say whenever you use anything with parentheses or the curly brackets, curly boys, whatever you want to call them, it's like you're making a sandwich. Always put the open bracket and the closed bracket, then go into the middle and write the fillings of the sandwich. Okay. Yes, I'm missing a closed bracket. Now, this is a place where GG equals capital G. Remember that? GG equals capital G is your friend. If you actually reformat your file, watch this, it'll actually kind of show you where the problem is. Right? So look at this. This if and the else if should be lined up. They should be vertically oriented with each other, and they're not. And so this is very, very clearly a mistake on my part. So if I come in here and try compiling the code again, you're going to see the message, I expected a closed bracket before I saw an else. And it'll tell you the problem is on line 9. But the problem is not on line 9. Here's line 9. The problem is actually up above, right? GG equals capital G. And everything's lined up again. Pretty cool, right? The problem wasn't with this line at all. And this is something you guys have to learn when you're doing computer science. A lot of times the error message you get comes from a line above it. For example, if I screwed this up, this guy with Y, let's say, then it will give me an error on line 7. But the error is not on line 7. The error was I misnamed my variable up above. Okay, so just be aware that when it tells you there's an error here, that's where it discovered the error. Okay, it doesn't necessarily mean that you need to fix things on that line, right? You might be missing a curly brace, a smooth parentheses, a variable name somewhere up above. Okay, so it's not necessarily the line number that is exactly the place where you need to make your fix. Are you guys with me on this? It's actually a really valuable point for you guys to learn. Madison, Luke, Brandon, you guys understand? When the compiler gives you a line number, it's not necessarily that line that is the problem. Okay. All right, so what kinds of things can you put into a conditional? That expression, that smooth parentheses. What can you put inside of it? Well, you can do less than, you do greater than, less than or equal to, greater than or equal to. And remember, you do the less than first, then the equal. Some students in the 12 o'clock class, like I said, were switching those and it wasn't compiling. Double equals, remember, double equals is comparison, single equals is assignment. If I wrote code that looked like this code is technically correct C++, but is this comparing x to 0 or is it setting x to 0? What do you guys think? Yeah, it's setting x to 0. Is that probably what the user was intending to do, the coder? What, if you saw this in an if statement, would you expect x to just change in the middle of it? You got some code that's like, if x is less than 10, else if x is less than 20, else if x equals 30. You know what I mean? Do you think that this is correct code? It's technically correct C++. You might get a warning for it. It's not an error. But would you expect the value of x to be changing in the middle of a big conditional? Where you're like, oh, if it's this value, do one thing. If it's this value, do another thing. Change the value now. If it's this value, do this thing. Like, do you guys think this is what the programmer was intending? What do you think? No, probably not. Let's see what kind of error we get. Well, it's not going to be an error. .cc. And so we are getting a suggest parentheses around assignment used as truth value. So it's a warning, but it's warning you, you're probably wrong. A lot of warnings are warnings you should not ignore. Almost every warning, with a couple exceptions, you should never ignore them. And if you don't know what they mean, like ask somebody, like, hey, I'm getting this weird warning, like it's telling me to put parentheses around it. And so I went and I put parentheses around it. And G equals capital G. Did I forget one? DLC. Yeah, it told me to put parentheses around it, and then well, it shut up. So it seems to work, but my code's not working right. Yeah. Don't just do things without understanding, right? In computer science, if you don't understand something, go on to the help center and be like, hey, I'm getting this warning. I don't know what it means. Please explain it to me. If you just sort of blindly change your code, if you just sort of blindly flail about and change things, like your computer science career is going to be horribly, horribly painful because you don't understand what's happening. And it's a simple mistake. And so, like, when I'm mentally writing code, I will actually say out loud, if x double equals 30. Okay. I don't say if x equals 30. I will say if x double equals 30. And the reason why I say that is because I have this narrative going inside of my head. Okay, now write if x equals 30. And if I say to myself, all right, now write if x equals 30, I'm going to write if x equals 30 a certain percentage of the time. So I've trained myself to say if x double equals 30. And that is a comparison. Okay, so that is comparing the value of x to 30. It returns true or false. I'm not setting the value to 30. This is a really important mistake that just comes up a lot, right? Where students get 1 equals and 2 equals confused. Do you guys understand? You guys good with this? One of the most common bugs in computer science is that. All right. Well, I mean, you can argue that like forgetting a semicolon is more common, but like forgetting a semicolon, like that doesn't really trip people up, right? Because it'll just be like, yo, I expected a semicolon. You know, you're like, oh yeah, I forgot a semicolon, and then you fix it, and you're done. You know, so there's a lot of simple mistakes that people make that like aren't actually a problem, because like even experienced programmers will forget semicolons occasionally, and we're like, oh, I forgot a semicolon, and you fix it, and that's it. You move on with your life. It's not a big deal. The bugs that really get us are ones like this, where suddenly the value of x is changing, you know, in the middle of an if statement, and that was probably unintended, you know, behavior. And now x down here, you know, if you were to see out the value of x, you were going to be desperately. Read was not declared, right? You're going to be shocked. Yeah. Oh, please enter the value of x. So if I put in 1, it prints out A, it works. The value of x is still 1 afterwards, right? So I can even come down here and say, you know, x is equal to x. So if I type in 10, prints out B, the value of x is still 10. If I type in 30, the value is C, and the value of x just changed, right? So, and it won't do D ever, because setting x equal to 30 returns 30. 30 is true. So in C++, this is actually a good learning point. Learning point. In C++, false is 0. Everything else is true. Okay? And so if you set x equal to 30, that returns the value of 30. Is 30 true or false? I'm asking you guys on chat. Is 30 true or false? When you set a variable, that expression returns the value that was set. So x is now 30, but it evaluates to be 30. Is 30 true or false? What do you guys think? 30 is true. And so this branch here is now dead. In other words, it can't ever be reached, because here, if x is less than 10, it prints A. If x is less than 20, it prints B. Otherwise, x gets set to 30, and that's true, and that will always launch, and this one will never. So you will never be able to get D. Like I said, this bug here is lethal. It is an extremely dangerous bug. And if you get a warning just saying, oh, just wrap a parentheses around it, it'll be fine, and you don't know why, problems. You will get problems. Ask somebody else, hey, what does this mean? They'll look at it and be like, 1 equals is assignment, 2 equals is comparison. Everybody repeat after me on Discord, please. 1 equals is assignment, 2 equals is comparison. This is something I have every one of my CSci classes since 2015. Repeat after me, and you just got to repeat it a few times. 1 equals is assignment, 2 equals is comparison. 1 equals is assignment, 2 equals is comparison. Okay. I want everybody on Discord to say that. 1 equal sign is assignment, 2 equal signs is comparison. Okay. So double equals is comparison. The bang character, the exclamation mark character, is not in computer science. And so, good. Thank you, everyone, for participating in this time-honored tradition in the computer science department here at Clovis Community College. So, 1 equals is assignment, 2 equals is comparison. And not equals is bang equals. All right, not equals is exclamation mark equals. So if we do this, if x not equal to 30, 10 is still B, 1 is still A, 30 is now D, and 100 is now C. Because 100 is not equal to 30. So it prints this one. If we do 30, then it does D, because that is false. Then if you want to make more complicated if statements, there are and, or, and not. And we'll probably go into more detail on these later, or maybe not. Maybe we can cover them today. Before we'll have you guys a little half hour of lab time to put this into practice. So these two things are equivalent, by the way. Most old school computer science people, you will see them use ampersand. That is the shift, what was it? Shift 7, the ampersand character. 2 ampersands means and. I personally just like typing and. And the reason for that is because there is another and operator called the bitwise and operator that is a single ampersand. And vertical slashes mean or, but single vertical slash is bitwise or. And it's not what you think. And if you type one of those by accident, then you oftentimes get bugs in your code that you didn't expect. So I actually just like typing X or Y instead of X vertical slash Y. It's just a personal style opinion. A lot of people, their heads will explode when you see that because it, even though this has been around for a long time, they're not aware that you can actually do that. So let's make a Y in here. Send the value of X using the value of Y. Wait to the bottom of the file. Okay. So if X is less than 10 and Y is less than 10, then cout pandas. Else if X is less than 10 and Y is greater than 420, cout 20. Else if X is greater than 50 or Y is greater than 50, cout Denny's late night menu. Else cout eaten green tea. I'm not really sure what the theme is for this one, but there you go. Okay, so let's give some examples here. I could compile it and run it, but let's just do this. So let's say that the value of X is equal to 10, and the value of Y is equal to 10 as well. So let's evaluate this one line at a time, and then I'll maybe type in some other numbers and let you guys run through it in your head. Okay, so is it true that X is less than 10 and also Y is less than 10? What do you guys think? Is it true that both X is less than 10 and Y is less than 10? Nope, in fact, neither of them are true. But even if one of those was wrong, the whole thing would be false because both of them have to be true. And in this case, neither of them are true. Okay, let's come over to here. Is it true that X is less than 10 and Y is greater than 420? Nah, not even close on that one. Y is much less than 420. So come down here. Is it true that X is greater than 50 or Y is greater than 50? So for this one, if one or the other one is true, we're going to print out Denny's late night menu. Is this true? Is it true that either X is over 50 or Y is over 50 or both is over 50? X is 10. Y is 10. So nope, both sides are false. So nope, it will not print out Denny's late night menu. So then what does it print out to the screen? E2 and green tea, very good. All right. So What if we had y equal to 500? What is that going to print to the screen? Again, you have to evaluate these things one at a time. Kid Cudi. So is it true that x is less than 10 and also y is greater than 420? Nope. X is not less than 10. X is equal to 10. It's not less than 10. So for an and, both sides have to be true for the whole thing to be true. With this one, we have a true on one side, we have a false on the other side, and so the whole thing is false. All right. So Kid Cudi is not going to get printed because x is not, in fact, less than 10. Both x has to be less than 10 and y has to be over 420 for to print out Kid Cudi. All right. So we got some votes for Edwin green tea again, which I would like because it's delicious. But I think we might have a winner here, right? See, for this one with an or, either x has to be greater than 50 or y has to be greater than 50. Or both. In this case, y is in fact greater than 50. So it's going to print out Denny's late night menu. All right. So this is going to print out this. Right. Now, what if I change x to be 500 as well? What is this going to print on the screen? Run through it a line at a time. Yes, it is in fact going to do Denny's late night menu again, because this is false, that's false, that's false, that's true, but you need both sides to be true for it to print out Kid Cudi. So yeah, it's going to print out Denny's late night menu again. All right, what about if x is 5 and y is 0? What is that going to print on the screen? We'll print out Panda Express. Yes, I changed it on you for you who were typing. We'll now print out Panda Express. Panda Express. I don't know. Orange chicken, maybe. All right. And then what if we set this to be 500? What is this going to print on the screen? Panda Express again? Is y less than 10? Yes, we'll print out Kid Cudi. All right. Neat. All right. So now that you guys know this, I think we've got all this covered. All right. Harambe, Kanye, memes, melt steel beams. All right. Then what I want you to do is I'm going to pause the stream and I'm going to give you guys half an hour to write from scratch on a blank file. So a lot of students don't even know how to edit a blank file. So if you just type vim and like the name of a file, like 816.23. If I can type cc, that will edit a blank file. So just make it, this isn't being graded. You can ask for help with your friends, whatever. Just create a new blank file from scratch, type in the magic, type in the, have it at the top here. You know, this is the boilerplate code we start C++ programs with. Hashtag include IOStream, using namespace standard, int main, curly brace, close curly brace. Okay. So start with that, and then you're going to write a program that inputs somebody's name, age, and income. If they are rich, and you can define rich however you want, you're going to output welcome rich person. If they are poor, you're going to say, sorry, the bank is closed right now, and then quit. And then probably charge them a late fee or something like that, just to add insult to injury. Compute how much they can save for, then, once you get past that point, in other words, they're not poor. Compute how much they can save for retirement if they put away 10% of their income each year. So retirement age is 65, let's say. So if they're 50 years old and they're putting away 10% of their income per year, then you can compute that using your powers of algebra. Ask them how much money they currently have saved away. That'll add to the number in 2. And then ask them how much they want to live on. So like, let's say they want to live on $50,000 a year. If they get 5% of their money, then they would have to have 20 times that amount to live on the interest alone. So basically, at the end of it, you're going to say, hey, you're on track to meet your retirement target, or you're going to output better start working more, or get used to eating cat food, or move to Hemet or something like that. So is there a certain directory you should do this in? Nope. Just put it wherever you want. So some students put it in a lab directory. This isn't going to be graded. This is purely just going to see, do you guys understand if statements? Can you write it yourself? This is something I hammer over and over again, is like, you can listen to me all day, but you have to write the code yourself, and you're going to have to write code over and over again until it becomes second nature for you. Okay, so lab time begins now. You have half an hour, then I'll show you guys the answer. All right, pausing the recording. And we're back. Here is the answer. So plus equals, minus equals, okay. Actually, this is not it. Never mind. A second. There it is. Move some of the files around. So please enter your name. A lot of you guys did things like please enter your name, C in the name, a variable for the name. Now, problem here is that name should be a string, not an integer. Strings hold words, integers hold numbers. So this is not going to work. And this is going to output an uninitialized variable here. So it's going to say, please enter your name. And it's going to print out 5,000 or 0 or something. And then it's going to cin into an integer, which again, should be a string. Age should be an integer. That's fine. Again, don't output this. Like when you guys do a cout statement, what goes into the cout statement is the things you want to appear on the screen. You have to understand cout means take whatever you have there and put it on the screen. And this is going to put an uninitialized variable on the screen. This is another reason why I say every time you make a variable, give it a value, especially for integers and doubles. Strings, you don't have to. They'll default to an empty string. But this is good. This is gonna cause pain and suffering. Welcome, rich person. Else, sorry, the bank's closed right now. So a poor person for you is anybody who makes under 10,000. Okay, I guess we can work with that. If age is less than or equal to 65, then you compute how many years they have until they retire, multiply by income, multiply by 10%. But the double left arrow inline here, no, that goes with a cout statement. And this is I'm not picking on any one particular student. This is a very common problem I see with computer science people in the first couple of weeks, is they're not really sure what a cin and a cout are for. That's almost why I would recommend you guys use the print function. The print function, it's clear, it's printing to the screen something, right? This double left arrow inline is like hitting return when you're couting something, but it doesn't do anything here. And in fact, this will not allow it to compile. And name should not be saving this as name, right? So let's go ahead and look at another one. So your income, C into X. Yeah, I would probably not call the variable X, right? The only reason I'm using X for variable name is because I don't know what the variable is, right? And it's just sort of a generic name for a variable. But we do know what this variable is. This is the income, right? And so you're having the bank close if they're too wealthy, if they're too, well, not wealthy, if they're too rich, if they have too much money coming in. So the assignment was for the bank to refuse to let poor people in and to charge them a non-sufficient funds penalty for being poor, which is a real life story. I was once billed money by Wells Fargo, fined by Wells Fargo for not having enough money in my bank account 3 days prior to the auto payment going through. I had an automatic payment of like $20 set up. I had like $10 in my bank account because I was poor. It was college. And I put money in before the deadline, and it had cleared and everything. But they charged me a penalty for not having money 3 days prior to the payment in my bank account. And that $35 fee drove my bank account into the negatives, which then caused everything else I had to bounce and they charged me bounce check fees. And all told, like this was just like for like 2 weeks, just everything was bouncing and it was just this crazy mess. I finally got it sorted out by yelling at them a lot, but it definitely did not endear me to Wells Fargo as the result of that. And I call them, I'm like, what do you want me to do? They're just like, have more money. And I'm like, well, great, thanks. That's a great answer. Just have more money in your bank account. Sure, let me wave my magic wand and do so. It's a lot nicer when you have money. And then they're all nice to you, and they're like, oh, I'll put a note in your account not to charge you any money, for fees or whatever. But yeah, okay. So we got here X, and it says welcome rich person. That should be inside of here. This part here should be inside of here. Please enter your age and income. Scan into the age if the age is less than 65. You've never inputted the income though, so you're actually multiplying. You're doing a multiplication with income without income. Well, I mean, first of all, this variable declaration is wrong. It should be int num income or int income equals something. Again, never initialize a variable without a value. I know Zybooks will teach you to do that. Please don't do that. Always initialize an integer. Always initialize a double to a value. And then welcome rich person again. Okay. One more. See out. Okay, so this is another very common mistake that people make, especially where you guys are at right now. The double left arrow is a double right arrow here. So this is backwards. So it's see out double left arrow. So the data is flowing into the screen, and then the data flows from the keyboard into the name. That double left arrow, that double right arrow should be a double left arrow, like it is here. String name, int age, good. The variables are created correctly here. They're initialized. Even though you're going to input into them, as we've seen with the previous two examples, it is quite common for people to accidentally use a variable that is uninitialized, and that creates chaos and unpredictability, which is one of the worst things in computer science, because your code might work 99% of the time, and 1% of the time it doesn't. It becomes very, very annoying and very difficult to track down the bugs. So just always initialize your variables. Trust me, you'll thank me for it later. Student income, if we are making over $10,000, which is a rich person apparently, but that semicolon right there, yeah, that semicolon, that's saying if your income is over $10,000, do nothing. That is why, you should use the curly braces when you're starting out. Same thing with this else here. You have fake indentation here. That semicolon should not be there. That should be an open curly brace, and then there should be a closed curly brace after those two lines of code. So semicolons after an if statement and else means do nothing. So if income is over 10,000, do nothing. Then it's going to print out welcome name, and then that else is not even going to compile because it's not attached to an if statement anymore. It has to follow the if statement immediately. It doesn't, so that's not even going to compile, and then it'll just always print these two lines. So very common mistake that students make right there. Okay, let me just show you the answer. So you make a variable, and if you use the read library, you can initialize it at the same time. And that's why a lot of you guys weren't initializing your variables. You're like, well, we're about to get the value from the keyboard. It's okay for it to be uninitialized for a little while. But as we see, people will screw up and accidentally print the value or something of an uninitialized variable. And down that path leads chaos and destruction. So the read library is superior to using CN. It just is. If you want to use it in your homework, hashtag include this. Okay. /public/read.h. All right, so we read in the name, we read in the age, we read in the income. If the income is over 1 million, the single apostrophes there is like a comma. And so if you delete them, it doesn't change anything. I can put it like that. It's just harder to, you start looking and you're like, is that 1 million? Is that 100,000? You're like 1, 2, 3, So putting the single apostrophes, the single quotes in there breaks it up, and you can count, okay, that's exactly 1 million. Doesn't do anything. It just makes it easier to read. Yeah, I can post the prompt so you can look at it your own time. So if you're over $1 million, it says welcome rich person. If your income's under 10,000, it says sorry we closed. Penalizes you $35 per year for the rest of your life, and then quits, returns 0. We'll quit from main. We then read in how much you've saved. If they're under 65, then we do a little algebra and compute 10% of their income until they turn 65. Add that to the money they've saved up. We ask them how much money they want to live on. Multiply that by 5% to figure out how much. So if they have $1 million saved up, we multiply it by 5%. Like, okay, you have $5,000 a year to live on, and we try to see if that is enough to live on. If they want to live on $50,000 a year, and they're going to make $5,000 a year, it's not enough. So it'll say, "I hope you like eating cat food." Otherwise, it'll be like, "You're good." So those are if statements. You're going to get your next homework assignment on Friday, and it'll be an if statement based homework assignment. Your current homework assignment, elementary, if you haven't finished it yet, you need to have it finished by noon on Friday. In any event, thanks everybody. Peace out. I'll post the lab instructions for today so you guys can work on it at your own pace. Okay? Peace.